Please don't go too far away. There's a presentation of a memento to be made. I shall call upon Mr. Gautam Banerjee to hand over a memento to Mr. Sanjay Chatterjee, CEO, Ideal Analytics. It's time we moved on to the next speaker of this afternoon. He'll be speaking about transforming long-distance mass transportation through analytics. He's Mainak Sen, Director, Business Brio. A word or two about him. Mainak Sen is Director, Business Brio. Mainak is a graduate in production engineering from Jadavpur University, Kolkata, and an MBA from Michigan State University, USA, with specialization in operations research. Post-management studies, he was a research scholar at Purdue University. He has worked with New York Stock Exchange and NASDAQ listed global companies in India and in the USA. His last corporate engagement was with the Ducker Research, US. He has deep interest and experience in Lean Six Sigma and operations, excellence and methodologies. It would be quite poignant to point out here that Business Brio is the recipient of the prestigious NASCOM Analytics Excellence Award for 2015. Mr. Mainak Sen, please.
Good afternoon, everybody, and thank you to NASCOM and the Data Science Foundation for giving me the opportunity to address you all. I feel a bit humbled following the three illustrious speakers that we had prior to myself, and I'm really a student of analytics, so I really am not that much of an insider as some of my other friends and colleagues who preceded me. But anyway, I will just try to give illustrate a few cases about the applications of analytics to mass transportation systems, and I will specifically look into application of analytics in railways. So what we have is like we are having this is the era and the age of smart people, era of smartness. So we have smart cities, and now we have smart railways, railway systems. Now it basically comprises of solutions, devices and components and services, and the goal is to automate and optimize the railway use of railway infrastructure to carry out advanced functions, and we'll see a few examples of what those advanced functions possibly can be. And this entails several components. So we have the passenger reservation and information systems, which caters to the human traffics, then freight operations. Of course, many of the railways, including our own Indian Railways, freight is their driver for revenue. So that's extremely important, but maybe not as visible to the daily consumers as us. Then on the operations side, you have things like traffic management, where analytics is playing an increasing role. And then, of course, assets management, assets being the tracks themselves, the locomotives, the rail cars, and whatnot, everything that the physical assets as well as the human assets. And then things like security, IP-based security tracking. Now, this is based on a study that a market research industry study that was done last year and was published only early this year, and it points out specifically that the drivers emergence of advanced solutions in analytics. The challenge is the high operating and maintenance costs. Naturally, for railways, most of the railways in the world, if you look at globally, we are talking about very big networks and distributed assets covering entire continents. For example, in the cases like US, so operating costs and maintenance costs are very high, and this actually leads to operating costs and high maintenance cost even for the analytic solutions. So that's always a challenge. You have to keep your costs manageable. And the key trend is the adoption of analytics and big data. Now, railways, even if you take the example of our own Indian railways, this is almost by definition very ripe for big data. Everything about railways is big, and it really translates to huge volume of data from multiple sources, different type of data, so volume, veracity, velocity, all the 4 V's of big data are really there in things like railways. The analytics marketplace, market space rather, is really coming up in a big way. It's expected to grow around at around 27% year to year over the next 5 years. And the 3 segments, as I mentioned before also, so you have the solution space, devices and components, and services. So globally, if you look at some of the players, the big players, ABB, Alstom, Bombardier, GE Transportation, and you can immediately make out that these are the same people, these are the same companies who are very much in the, who are there in the transportation industry. So all of them, for example, GE, if you take the case of GE and ABB and Alstom, they themselves make locomotives. So it's natural for them to do that forward integration and also provide the analytic solutions because they are making so much of the hardware and the dedicated software that goes in managing those hardware. So it's a natural extension for them to provide the analytic solutions also. We have also a significant amount of Indian presence, Indian corporates, L&T, TCS, Tech Mahindra, Wipro. They are also getting into this domain of railway analytics. Now just coming to a little bit of the detail about what exactly is meant by railway analytics. Now analytics, even in railways, like in so many other fields, it has been around for quite a bit. I mean, ever since the advent of computers and the adoption of computers in mainstream industry, we have had analytics. Now it's a different story that there's all this hype, some will call it, that has been created over the last decade, maybe last 5 years in particular. But analytics has been around for quite some time. So things like demand prediction and trying to identify accident prone zones, those have been around for decades. But what has changed is the character of the data and the amount of the data. Previously the data resided centrally. I mean, the operating company, for example, let's say Indian Railways, they collected the data was with them, it was kind of static. So data collection happened at discrete points in time. What has changed now is that you have data from varied sources. Most of the data collection is happening in real time, and you have things like GPS, automated equipment identifiers, electronic data interchanges, and things like video inspection. So instead of deploying human beings to do inspection of coaches, you are just capturing photographs from cameras that are inbuilt in the coaches, and you can just compare those videos from two different points in time and do an inspection sitting somewhere in a remote location. And handheld field tablets. So things like people are using handheld field tablets to inspect tracks, when they're inspecting railway tracks. So this is what makes it ideal for big data analytics, because you have the analytics angle as well as you have a natural application of big data technology because of the volume and the veracity of the data. Common application areas, so you have travel demand modeling, train signal and control system, that's more of a back end, route planning and scheduling, then automatic vehicle location, automated fare collection, automated passenger counting. I'm just giving you the few more common ones. There are probably hundreds of different other applications in the railway domain. This is just a very high level architecture of the kind of system that you have, and number of companies. I was just reading yesterday, for example, and companies like Xerox, and I was a little surprised to know that Xerox is actually doing something like this. They have come up with what they are calling is a mobility application platform, and they are using that, and they have tailored that for application in the railway domain. You have this entire mobility platform that they have built, where it is integrated with things like handheld devices, and it's collecting data from thousands of data points, and at consumer level, at railway operations level, and it's flashing it up in a dashboard, and that's operational. I think they are doing a trial in the Adelaide City rail network. I will take briefly talk about three particular case study example cases, just to give you a flavor about what railway analytics as applied to railways look like. So the first one is the Bay Area Rapid Transport System, based out of San Francisco. So what they have is, what they're doing is passenger flow modeling. So you have monitor the motion of passengers through the system. Did the passenger reach his destination on time comfortably? Now, interestingly, what they are doing is something very similar to what we have in our own Calcutta Metro. You have this, in fact, this Metro card. So you swipe the card, everybody has a card, you swipe the card, and this is basically your ticket. So once you are in the station, this is your ticket, you swipe it once you enter into a platform, and then again while coming out of the platform. Now they have something very similar to this, and the only difference is that it has a PID, a passenger identification tag attached to this, and every time you swipe in, the time you swipe in and the particular station that you are swiping in gets logged, and then again while you are swiping out, the same thing happens. The time you swipe in, swipe out, and the station that you are swiping out gets logged. And this actually the system in the back end, it actually measures the time difference, so how much time you are actually spending in the system, and it is being historically monitored. So most of the people, like in most of this mass transit system, there are a large number of people who are traveling, taking the same train in the same route. Maybe they're just commuting from home to office, and they're using the same train, the same route every day, and so it's monitoring the actual time that it's taking the person every day. And this they are doing for each and every passenger, and they are trying to dynamically first forecast the ridership, and then trying to schedule the trains in such a way that it benefits both the customer as well as the operating railway. The customers, because the customers would naturally don't want to get into a train when it's overcrowded. So it's trying to schedule the trains in such a way that whenever there is rush hours, you are scheduling trains more frequently, and this is happening dynamically. And at the same time, you do not want the trains to be too vacant, because that increases the cost of the operators, right? And so it's kind of optimizing everything in a dynamically in real time, and this of course is based entirely on analytics. So this is something that that's one example. The second one is again from the United States, Pennsylvania Transportation Authority, and they run both train services as well as local bus services. And the thing that I was looking at was something called, what they are calling PTC, which is Positive Train Control, which actually is an extension of what used to be called ATC, which is Automated Traffic Control for railways. And what they have done is they have enhanced it using GPS data, live GPS streams, and with the installation of specialized devices in locomotives and rail cars. And they have integrated it with a big communication network. And I'm sorry, it's the bottom point is kind of not visible. And wayside devices, that's all near the tracks. And what the target here is that they have a mandate from the government that all train traffic must be restricted with certain civil speed restrictions and certain stops. So that speed restriction and stoppage of trains, this is something that they are again trying to do it in real time using analytics. This is also, apart from this PTC, they are also providing something very similar to what the Bay Area Transport Authority is doing. They are providing PIDs with customer, and again they have come up with this Android and iPhone based apps where they are integrating the data from the customers directly into their system, and again doing using it for forecasting as well as optimizing their railway operations, things like scheduling. The final example is a little interesting. I find it very interesting because it's right from our country, and I don't know how many of you have actually visited this site. It's called Trainman.com, and they are doing some, I'm sorry this is not very clearly visible, but I will explain what this one is showing actually. I mean, we are, anybody in India who does any amount of travel in Indian Railways will know that getting tickets is a very big deal. So, and you have this 120 days reservation window, and for most of the popular trains, you know, most of the popular trains you do not really get reservation. And what this company has come up with is that it is giving you a prediction model. It's giving you a prediction, a confidence level, a confidence interval for your chances of getting a ticket on a particular day on a particular train from one city to the other. So for example, I just had this screenshot. So suppose you are traveling from, you want to travel next week from Kolkata to Delhi in Rajdhani Express. Right now, as it is showing here, probably I'm sorry you cannot see it. What is showing here is that it's saying that for AC first class, AC 2 tier and AC 3 tier, none of the tickets are confirmed. No confirmed tickets are available, but it is giving you tickets are available for booking under wait list, and it is, what is interesting is it is giving you a probability. It is giving you a probability of what is your chance of that ticket actually getting confirmed. So for example, it's showing something like 88% for AC first class, 100% for AC second class, and 100% for AC third AC. So this is something really helpful for people who are who take the train pretty often, and this they are doing for each and every train, and from any place to any place. So this is really remarkable. And they're also, and their entire analysis is based on past trends of the history of how tickets have been confirmed in the past. And what I particularly find remarkable about this is that you note that this is not something that the Indian Railways is doing. It is a third party. It is a third party, some analytics company which has come up with this, and I think it's a remarkable, straightforward application of analytics. I'm not saying that it's simple. It's really actually, if I want to venture, I think the back-end model that it is running is pretty sophisticated. It's a pretty sophisticated mathematical model that's running in the back-end. But the problem that it is addressing, if you think from it from the consumer's perspective, couldn't be simpler. And it really is something which I feel is adding a lot of value. It's something really gives you, it's a very good example of how you can use analytics in day-to-day life. So this is what they are doing. If you have a ticket, if you have a PNR, you can just plug in the PNR in their website, and they will tell you what's your chance of what's the chance of getting that ticket confirmed. So that they have done it at that level. That's all I have. If you have any questions, feel free to ask. Yes.
Hello. In one slide, you mentioned that optimization. So, can we apply the principles of operational research into the controlling the transport? Or can we apply some principles of operational research?
Absolutely. Operations research originated from transportation problems. So you can.
That is the game theory as well we can apply, right? So basically the oblivious router, you may have heard oblivious.
I'm sorry, I haven't heard about it.
Okay, but it is a principle of Nash equilibrium in computer network traffic. I read in an article sometimes back. Possibly, but I have never heard about game theory being applied to network traffics, but anything is possible. I don't know. So, thank you.
Just a very trivial thing. In that BART case study,
yeah.
you said it measured whether the passenger reached his destination on time and comfortably.
Correct.
You explained the on-time part. Were they measuring the comfort?
By comfortably, I meant that, so if you know the time, if you know the time and you also know which train he took, right? And now if you have the accumulated data of all the passengers during that time traveling from from the same source station to the same destination station, you will know how many passengers were there in that train, right?
Okay.
So how crowded was that train?
Okay.
By comfortably, I meant that
Right. Thank you.
was it a too crowded train or was it comfortable in
Thank
that
you.
sense? Oh.
Hello sir, I liked your presentation on the railway analytics. My one question to every presenter here is, we try to understand how analytics has changed in terms in USA, and we have relevant case studies there. And you yourself has mentioned that there's a third party tool of Trainman.com who's trying to analyze the probability of getting a ticket of confirmed ticket. So just wanted to understand what is the scope of railway analytics in India in terms of Indian railways. Like, what is your view on that? How much it has penetrated? What is the level right now?
How much has analytics penetrated in Indian railways?
Yeah.
I will not be able to, I don't know how much I know about Indian railways, but what little bit I know is that Indian railways is moving big time into automation of systems that they have been doing for past decade or more. And so a very important part of that automation process is collecting data. And so that data is already available. A vast amount of data is available, and the infrastructure to collect that data is already available within the Indian railway system. But I think analytics as such is probably still in a nascent stage. So they have the data there, so they have the raw material with which to work, but they are, I think, just in the process of coming up, developing the recipes to convert that raw material into information.
Thank you, sir.
Okay, that would be all. Thanks a lot.